Stop and consider what you're actually being asked to believe. A camera bolted to the outside of the most monitored vehicle in human history captures something the agency operating it cannot, or will not, identify. The feed goes blue. The transmission cuts. And then comes the explanation, polished and procedural, arriving exactly when explanation is most convenient. You don't need to be a conspiracy theorist to feel the friction in that sequence. You just need to be paying attention. The question isn't whether something appeared on screen. The question is whether the story you've been told about what happened next can survive a closer look. The International Space Station orbits roughly 408 kilometers above your head right now. It moves at 7.6 kilometers per second, which means it completes a full lap of the planet every 92 minutes. Its orbital inclination sits at 51.6 degrees, a number chosen decades ago so that Russian launches from Baikonur could reach it without burning excessive fuel. The station is not a quiet object. It's tracked continuously by United States Space Command, which currently catalogs more than 27,000 discrete pieces of orbital hardware, from active satellites to flecks of frozen coolant the size of a peanut. Anything that approaches the ISS is, in theory, already in a database somewhere. Between 2014 and 2019, the station carried an experiment called High Definition Earth Viewing, HDEV. 4 commercial off-the-shelf cameras mounted on the exterior of the Columbus module pointed at the planet. The purpose was modest. Engineers wanted to learn how consumer-grade imaging hardware degraded in low Earth orbit, exposed to radiation and thermal cycling. The byproduct was something far more interesting to the public. A nearly continuous publicly streamed window onto the limb of the Earth, the curve of the atmosphere, and occasionally, the empty black beyond. HDEV failed permanently in July 2019 after its electronics gave up earlier than predicted. But during its 5-year run, it accumulated a strange afterlife in internet culture. Because every so often, the feed would catch something. A glint of light moving in a direction that didn't match the station's motion. A streak crossing the frame too fast to be a satellite. An elongated shape that hung in view for half a minute, then vanished. And almost always, sooner or later, the feed would cut to blue, to a static color card, sometimes paired with the words signal acquired or no signal. To viewers watching live, the timing felt deliberate. To NASA, the timing was routine. 2 completely different stories about the same 30 seconds of video. That gap is where this episode lives. The clip most people remember showed up on a Sunday in April 2016. An astronaut named Scott Kelly was nearing the end of his year-long mission aboard the ISS. The HDEV feed was running its usual rotation when an object appeared. In the upper portion of the frame, slightly above the horizon, it was bright. It was steady. It appeared to track alongside the station, for what witnesses estimated at roughly 20 seconds before the camera angle shifted and the feed transitioned to its standard blue interlude. Within hours, clips of the encounter had been pulled, mirrored, slowed, zoomed, annotated, and uploaded across every video platform in existence. Some viewers counted as many as 8 separate objects in different parts of the same broadcast that week. 2 years earlier, in January 2014, a similar event had circulated under the label The Long Object. That clip showed what looked like a slender, structured silhouette holding position against the curve of the Earth before the HDEV feed transitioned. The official explanation at the time was loss of signal. Loss, a term with a long pedigree in human spaceflight, and an even longer history of being misunderstood by people watching from the ground. To understand what loss of signal actually means, you have to understand how the ISS talks to the planet it's flying over. The station does not transmit directly to mission control most of the time. Instead, it relays its data through a constellation of communication satellites in geostationary orbit, roughly 36,000 kilometers up. These are the Tracking and Data Relay Satellites, TDRS. They form a network that lets the ISS stay in nearly constant contact with the ground. Nearly, but not quite. There are geometric gaps, moments when the station passes through a window where no TDRS satellite has a clear line of sight, or where the relay handoff between satellites doesn't complete cleanly. During those windows, the live feed pauses. The video buffer empties. The screen goes blue. And when the next satellite picks up the link, the feed resumes. This happens dozens of times a day. It happened constantly during the HDEV experiment. It still happens to every camera on the station today. The duration of a typical signal gap ranges from a few seconds to several minutes, depending on the orbital geometry and the load on the relay network. It is, by every available metric, the most boring possible explanation for a video cutting out. And yet, when a signal gap coincides with something visually unusual in the frame, the boring explanation collides with a much more compelling story. The story that says they saw it too, and they didn't want you to keep watching. Dr. Lincoln Hines, a space policy researcher at Texas Tech University, has spent years studying the intersection of classified and unclassified satellite imagery. His work focuses on how governments decide what to release, what to redact, and what disappears entirely from the public record. When I describe the ISS feed incidents to him in general terms, he tells me the framing matters enormously. There is a meaningful difference, he explains, between classified imagery and operationally interrupted imagery. The first describes data that exists, has been collected, and is being deliberately withheld. The second describes data that was never captured or never transmitted in the first place. Loss of signal events, in his view, fall into the second category. You can't suppress what didn't arrive. But Hines also notes something that complicates the simple skeptical reading. He points out that the United States government does maintain classification authority over certain categories of orbital imagery, particularly imagery that resolves the surface details of sensitive ground sites or that captures the geometry of classified satellites. The ISS itself is not a classified platform. Its cameras are not classified instruments. But the policy infrastructure that governs what can and cannot be shown from orbit is real. It is layered, and it is not always transparent to the public. So when a feed cuts at a suggestive moment, the institutional reflex isn't necessarily cover-up. It might be habit, procedure, a reflex toward caution that looks, from the outside, indistinguishable from concealment. That distinction is the heart of the problem. Because the people watching the live feed are not watching with a flowchart of TDRS handoff timing in their head. They're watching a screen in real time, and the screen just did something dramatic. The brain fills in the rest, and once filled in, the explanation becomes very difficult to dislodge, no matter how many engineers explain the geometry of geostationary relay satellites. To press into the strongest version of the skeptical case, I went to Scott Manley. Manley is an aerospace educator with one of the most respected independent voices in spaceflight commentary, a former engineer at Apple, and someone who has spent more than a decade dismantling viral space anomaly videos one frame at a time. When I describe the canonical ISS object clips, he doesn't dismiss them. He categorizes them. The April 2016 Scott Kelly-era object, Manley argues, is almost certainly orbital debris, possibly an ice particle ejected during a routine waste dump or coolant venting from the station itself. The ISS routinely jettisons frozen liquid through external vents. Those frozen droplets reflect sunlight brilliantly. They appear motionless because they're moving in nearly the same orbit as the station that just released them. Within hours, atmospheric drag pulls them down, and they vaporize on re-entry. The 2014 Long object, in his analysis, shows characteristics consistent with a piece of insulation or a fragment of a deployed CubeSat antenna. NASA has used the ISS as a deployment platform for small satellites since 2012 through Nanoracks and other commercial partners. CubeSats released from the Kibo module's airlock drift away on slow trajectories, often passing back through the field of view of station cameras hours or days later. And then there are the categories that didn't exist when most of the famous footage was filmed. Starlink trains. Beginning in 2019, SpaceX started launching batches of 60 satellites at a time into orbits that initially clustered into bright, evenly spaced lines visible from the ground and from the station itself. Anyone reviewing modern ISS camera archives without knowing about Starlink would absolutely interpret those trains as formations of structured craft. They're not. They're commercial broadband hardware in transit to their final orbital slots. Manley walks me through specific clips. He points out lens flare from sunlight hitting the camera housing at oblique angles. He shows where atmospheric refraction stretches the apparent shape of an object near the horizon. He demonstrates how the low frame rate and aggressive compression of the HDEV feed produces ghost trails on bright objects that didn't actually exist in the real scene. His position is not that nothing strange has ever been seen near the ISS. His position is that every well-documented case examined to date resolves into a known category of orbital phenomenon once you apply the full toolkit of analysis. The mystery, in his view, is less about what's in the sky and more about what humans do with ambiguous footage when they encounter it without context. I asked him about the resupply incidents, because that's where the story gets more complicated. Cygnus, Progress, Soyuz, and Dragon spacecraft all rendezvous with the ISS on a regular cadence. Their approach trajectories bring them into the station's field of view long before docking. They appear, from the perspective of an HDEV camera, as bright objects holding station with the ISS for extended periods. Anyone watching a live feed without a launch schedule open in another tab would see something that looks exactly like a craft pacing the station. But there's a specific incident from 2008 that complicates the simple categorization. The European Space Agency's automated transfer vehicle, named Jules Verne, became the first ATV to perform an autonomous docking with the ISS. Its approach was monitored continuously. Its trajectory was published. And during one of its station-keeping phases, while it held position roughly 2,000 meters from the ISS during a series of demonstration maneuvers, it was clearly visible from the station and from the ground. There was nothing mysterious about Jules Verne. It was a known craft executing a known sequence. But the visual signature it presented, a bright structured object holding position near the ISS for hours, is essentially identical to the visual signature that drives every UFO near ISS video on the internet. The point Manley emphasizes is that the database of known objects in low Earth orbit is enormous, and the public familiarity with that database is almost nothing. So when something appears that doesn't match a viewer's mental model of what should be near the ISS, the default explanation becomes mystery. The technical reality is usually that the object is in the catalog, has a designation, and has been there for hours or days. The viewer simply doesn't have access to the catalog in the moment they're watching. So where does that leave us with the canonical cut feed clips? The April 2016 incident, when reviewed against the TBRS handoff schedule for that orbit, falls within an expected loss of signal window. The 2014 long object similarly aligns with a documented gap in relay coverage. The clips were not cut in response to what was in the frame. They cut because the network handoff happened to occur during the same minute that something unusual was visible. The coincidence is what makes the footage feel like a smoking gun. The coincidence is also exactly what you'd expect, statistically, given that the feed cuts dozens of times per day and the camera is pointed at a busy region of orbital space. Hines, the policy researcher, adds one more layer. He points out that even if NASA wanted to suppress imagery of an unidentified object near the ISS, The practical mechanism for doing so would not be cutting a live feed. The feed is recorded by hundreds of independent observers across the internet within seconds of broadcast. The clip exists in dozens of mirrored copies before any operator at Johnson Space Center could conceivably react. Pulling the live transmission would do nothing to suppress the footage. It would only confirm, in the minds of viewers, that something was being hidden. From an information control standpoint, cutting the feed would be the worst possible response, which leaves the explanation that the cuts are exactly what NASA has always said they are: routine, predictable, indifferent to what happens to be visible in the frame when the network blinks. If the simple explanation holds, the implications for what we think we're watching when we watch the ISS feed are worth thinking through carefully. It means the human brain is exquisitely good at finding patterns in noise, and exquisitely bad at correctly weighting prior probabilities. It means the cumulative archive of cut feed incidents represents not evidence of concealment, but evidence of how often two unrelated events can coincide given enough hours of broadcast time. 5 years of HDEV operation produced something like 40,000 hours of continuous video. At that volume, the number of moments where a bright object happened to be visible at the exact instant the feed transitioned is not surprising. It's expected, but there's a softer implication that I think deserves attention. The persistent cultural interest in these clips, the willingness of millions of viewers to study them frame by frame, says something real about the relationship between the public and the institutions that operate space infrastructure. People don't trust the explanations they're given, in part because the explanations are often delivered without the context that would make them feel sufficient. Loss of signal sounds like a euphemism when you don't know what TDRS is. Routine waste dump sounds evasive when you don't know the station vents ice on a schedule. The communication gap isn't a conspiracy. It's a failure of public spaceflight literacy that benefits no one. There's also a harder-edged implication that I don't want to skip past. The fact that no compelling evidence of unidentified craft near the ISS has surfaced in the publicly available record does not, by itself, prove that no such craft exist. It proves that if they exist, the HD, EV feed, and similar consumer-grade cameras have not captured them in a form that survives careful analysis. The standards of evidence in this domain matter. A blurry, bright object in a low frame rate feed is not nothing, but it's also not enough. The same footage that drives speculation also fails, every time, to deliver the resolution and continuity that would actually resolve the question one way or the other. And finally, the implication that the official explanation might be both correct and incomplete at the same time. Loss of signal is real. Orbital debris is real. Resupply traffic is real. Starlink trains are real. All of these account for the overwhelming majority of what people see in ISS footage. But the policy framework Dr. Hines describes, the layered system of imagery classification that governs what can be released from orbit, is also real. It does not, in his view, apply to HDEV footage, but its existence means the institutional posture around orbital imagery is more cautious than the public assumes, and that caution can produce communication choices that look, from outside, like something they aren't. You've now seen the cases that get cited most often: the 2014 long object, the 2016 Kelly-era footage, the recurring cut feed pattern that fuels years of speculation. You've heard the loss of signal explanation, and you've heard Scott Manley's frame-by-frame breakdown of orbital debris, ice ejection, Starlink trains, lens flare, and resupply traffic that accounts for nearly everything in the archive. You've heard Dr. Hines describe the difference between classified imagery and operationally interrupted imagery, and the policy infrastructure that sits underneath both. The evidence I find most persuasive points toward the boring explanation, the one in which dozens of independent technical realities combine to produce footage that looks dramatic but resolves into known phenomena under analysis. but I'm one voice and the strength of any investigation like this comes from the people watching it. So I want to hear from you. Which of these clips do you think genuinely resists explanation? Which ones do you think have been overinterpreted? And what would it take, in terms of evidence, to actually move your position one way or the other? Drop your analysis in the comments. Link the timestamps of the footage you find most interesting, and tell me whether you think the public is owed more context from the agencies operating in orbit, or whether the context that already exists just isn't reaching people in a form they can use. The investigation continues with you.